Let's talk about some properties of logarithms. And now notice what we've done before. We talked about properties of the logarithmic function. These properties are just of plain old logarithms. These are the properties that are going to help us whenever we start to solve logarithmic equations. So there are several of them. If you don't have a textbook or something like that that has these already written in there, then you may want to pause this tape from time to time and go ahead and write them down so that you can have them. Okay, everything that we're going to do now in order to solve logarithmic equations has to come from one of the properties. These are all the things that you're allowed to do in order to change things when it comes to logs. Okay, first things first. Here's our first one that says log base a, meaning it could be any number, of 1 equals 0. Well, this is true because if we were to change this over to the exponential form, then I would take the base, which is a, raise it to the other side, that's our exponent, equals the argument, which is 1. And that we know to be a true statement from our exponent rules. Anything raised to the 0 power is equal to 1. So we have to know this logarithm rule. Here's our second one that says log base a of a equals 1. Anytime the base and the argument match, that has to equal 1. Now, why? Well, let's change it over to exponential and we'll see why. The base of a raised to the other side, which is the exponent of 1, equals the argument, which is a. Now, we know this to be a true statement. Any number to the first power is itself. 5 to the first equals 5. That's always true. Okay, our next couple of logarithm properties, we have this right here. This says a raised to the power of logarithm base a of m is equal to m. Okay, this one is a little bit more difficult to see, but since this is already in exponential form, let's change it over to logarithmic form and you'll see that this is in fact a true statement. Because our base is a, I'm going to use log. So this would be log base a. Now remember, we just have to figure out where to put these things. So our exponent here goes over on the other side. That would be log base a of m. And then our argument is right here. So that would be m. Now isn't that a true statement? Log base a of m is equal to log base a of m. So in logarithmic form, it's absolutely there. I mean, those things are identical. So this is a true statement. Our next one says log base a of a to the r equals r. Again, this is in logarithmic form, so let's change it over to exponential and you'll see why this is true. If I take the base of a, raise it to the other side, which is our exponent of r, it should equal the argument, which is a to the r power. Now we can see that that is a true statement. So you have to know, first of all, these 4 properties of logarithms. Now there will be more, but these are just the first 4.